Alright, what's up guys? Welcome back. This is 9.5's notes. And I alluded to it earlier when I was talking about the tangent that we got a couple more ratios coming. And today we talk about the sine and the cosine ratios. So you're going to need a calculator again for this lesson. And basically guys, it's just a comparison of the two sides that we haven't done yet. So the tangent did the two legs of a right triangle. Sine will do the opposite in the hypotenuse. Cosine will do the adjacent in the hypotenuse. So check out our core concept here and see what we're talking about. So in this triangle, with respect to angle A, the tangent compared the two legs, like we said earlier, the sine will compare the opposite and the hypotenuse. So opposite hypotenuse. And then the cosine will compare the adjacent to the hypotenuse. So adjacent hypotenuse. So now the mnemonic device that's used across the country to memorize sine, cosine, tangent ratios is SohCahToa. Maybe you've heard this before, maybe you haven't. SohCahToa. The sine, you are reminded to use the sine with the opposite and the hypotenuse, the cosine with the adjacent and the hypotenuse, the tangent with the opposite and the adjacent. So this is what we did in 9.4. And it was the only one, so you didn't really have to memorize it. But now that you have three things to remember, SohCahToa. So the way you say the words remind you what goes with what. So when I see something that would need a cosine, I say, cosine. So CohCahToa. So ka is C-A-H, so cosine is adjacent over hypotenuse. And this is kind of like, let me back all this up. It's the division that is in between these things. So it's opposite divided by hypotenuse, adjacent divided by hypotenuse, opposite divided by adjacent. So SohCahToa, a popular acronym. When you guys go to college, friends from around the country that you meet will all know what SohCahToa is. All right, so let's see here. Let's practice our SohCahToa isms. So in this one, example one, we want to find the sine of S, sine of R, then the cosine of each angle. So again, we're going to use it's the acute angles. So first we're doing sine of S. So the sine of S opposite. So when I say sine, I think so in SohCahToa. So opposite is 63, hypotenuse is 65. All right. So then 63 over 65. When you, let me see, 0.9692 taken out to four places. Next, we want to do the sine of R. So let's flip the tracks here. So R is here. So the opposite for R is 16. Hypotenuse is still 65. So 16 over 65. Sine R, 0.2462. 0.2462. And then switch gears to the cosine of S. So now I'm back to S. Let me go like this. Back to S, adjacent. The adjacent side for S is 16. The hypotenuse, of course, is still 65. Well, look at that. We have that right up above, 2462. And then the cosine of R, maybe you can even guess what this is going to be. R is here. The adjacent, so when I think cosine, ka, so CahToa, so C-A-H. A, adjacent is 63, H, hypotenuse, 65. So 63 over 65, which is what we had up there for the sine of S, 0.9692. So there is just listing the sine and cosine for our two adjacent angles. And yes, you may ask, is this going to be the same? Mm-hmm. The sine of an angle is the same as the cosine of its complement. So you know these two angles here have to add up to 90. So because we have 90 in the triangle there, 90 for the two little ones, so they are always complementary. And yes, you will have sine of an angle is the same as the cosine of its complement. Fascinating stuff. Gasp. Oh no. All right, and here's that illustrated further. It's a core concept. Sine and cosine of complementary angles. The sine of an acute angle is equal to the cosine of its complement. So the first sentence there illustrates it. So real quick, if I look at example 2, the sine of 56 in terms of cosine. Oh, okay. Well, all I have to do is subtract 56 off of 90, find its complement. So then the sine of 56 is the same as the cosine of 34. Beautiful. All right, now let's get into the good stuff. Again, just like we did in 9-4, we have this situation with a triangle with some missing sides. Can't use Pythagoras, can't use 30-60s, 45-90s. Got to turn our attention to SohCahToa, our last line of defense in finding missing sides of right triangles. All right, so find the values of x and y using sine and cosine. All right, so I'm given an angle here. So 26, that's good. So let's find the sine first. Opposite is x, hypotenuse. So when I think sine, so, and SohCahToa. How Katoa? SohCahToa. All right, so we've got, remember the word comes first. So sine, or the abbreviation in this case, then the angle, 26, equals x over 14. Opposite over hypotenuse. So now my variable's on top, so this is the easier method. You just got to multiply both sides by 14. And you can do this all in your calculator. So let's pop up a calculator here. And we've got 14 sine 26. Again, make sure your calculator is in degrees. All right? So we're going to round to the nearest tenth. So that is looking like 6.1 to me. So x is 6.1. And of course, if you forget how you put the calculator in degrees, mode, and toggle down to degrees, make sure you're in degrees. All right, now we have to find the cosine of this. Use the cosine of this to find x. To find y, so we got 6.1 there. You could use Pythagoras. Right now you have two sides, but we're just going to keep practicing our SohCahToa. So now I have the adjacent is y, and the hypotenuse is h. So again, for my 26, this was my opposite, this was my adjacent, and hypotenuse is always hypotenuse, always a side across from the right. So I've got this time the cosine of 26 equals y over 14. So multiply both sides by 14. In my calculator, let's get that calculator back out. Now I've got 14 cosine 26. 12.6 is my value for y. And there you go. So x, y, using SohCahToa. All right, try the monitor progress next page. Pause it, pause it. Woo! All right, back again. So here we go, first three problems, just like our examples we just did. So you got sine D, sine F, cos D, cos F, Make sure you are checked out. Number 2, subtract 23 off 90. Cosine 23 is sine 67. And number 3, 65 is our reference angle. So opposite hypotenuse for T, adjacent hypotenuse for U, and make sure you get 7.3 and 3.4. All right, moving along. Now, some familiar triangles. Us guys, you guys, y'all, you guys know what's up with a 45-degree angle. So you got a triangle that's got a 45 in it. You want to know what the cosine and sine of 45 are. Check this out. Well, what would this triangle look like? It's a 45, 45, 90. 1, 1, square root of 2. There's your base one. You could put any numbers in, then you'd have them in front of the square root of 2, but you might as well just go take it all the way down to 1. So the cosine of 45, adjacent over hypotenuse, cosine of, and these are so huge in pre-calc and calculus. Oh my goodness, the 45s and the 30s. That's why this book is doing this right now. That's why you have these two examples right here. Cosine 45, adjacent over hypotenuse. Oof. All right. So now you can put that in your calculator. If you were going to rationalize it, this is how your trig teachers will have it. It'll be square root of 2 over 2. It'll just be a roll off your tongue when you guys take pre-calc. What's cosine 45? Square root of 2 over 2. Boom. It's just that common. You'll use it for your unit circle, all these other kind of fancy things. But for us today, we are going to roll with the decimal. Yeah, we can do it either way. So let me see. If I go in my calculator, 0.7071. And I should have that memorized too from back in my day. 0.7071. Very common. And the sine, of course, you know what's cool? Since it's isosceles, the sine is also square root of 2 over 2, which is also 0.7071. All right, since you're isosceles, the sine and cosine opposite and the adjacent are the same. So that's pretty cool. Example 5, cosine 30, sine 30. Well, let's see what our 30, 60, 90 reference triangle looks like. 30, 60, 90, 1, 2, square root of 3. So the sine of 30, where's my 30? Opposite hypotenuse, 1 over 2. Don't need to punch that in, that's 1/2. Cosine of 30, adjacent, square root of 3 over 2. And this one is 0.8660 in your calculator. Boom. So you can just double check, make sure your calculator is on point. Just type in sine 30.5. There you go. All right, 0.5. Oops, monitor progress. Pause it. See you in a sec. All right, there you go. Now, of course, the sine and cosine of 60 are going to be the flip of what the sine and cosine of 30 were. So there you go. Hopefully you arrived at that destination. Sine of 60, opposite hypotenuse, square root of 3 over 2. Cosine 60, 1/2. And again, check your calculator. All right, calculator, let's see if you got it. Cosine 60, better be 1/2. Yeah, there you go. So your calculator knows what's up too. All right. Final example today, lots of real world problems with sine, cosine, tangent with SohCahToa. So recall from previous lesson that the angle upward slight makes a horizontal angle of elevation. So we got this situation here, you're skiing on a mountain with an altitude of 1200. The angle of depression is 21. Find the distance x you ski down. So a fancy way of getting you into a SohCahToa situation. We have opposite and hypotenuse. So which one deals with opposite and hypotenuse, you might ask? Well, SohCahToa. So opposite hypotenuse, O and H. So there is your sine. So I use sine on this one. Then the angle equals 1200 over x. So now if you're missing your hypotenuse, you're going to have to do the old switcheroo because that's always the denominator. So the old switcheroo taught us to put x on the left, replace it with sine 21 on the right. So now in my calculator, that's just one step, baby. So 1200 divided by the sine of 21. All right, so big old number, big old ski slope. So 3, 3, 4, 8, and I think it wanted us to go nearest foot. All right. So 3, 3, 4, 9. That's feet. Baby, baby. All right, there's a little SohCahToa coming at you. Watch this again multiple times if you need it till you get the acronym down, party people. It's all about SohCahToa. How Katoa? SohCahToa. Peace.